Hello all. Today I have Simon Timms here with me. And today we'll be talking about Pulumi and Ozcode. Our friend Microsoft MVP Simon Timms will be talking about both Pulumi, which is an exciting new DevOps technology which enables us to write infrastructure as code in C#, and the exciting new Ozcode Production Debugger, which is our new product, which enables you to debug code that's running in your QA, staging, and production environment through a web-based debugger. And with that, I'll hand it off to Simon.
Great, thanks so much. Exactly what Oma said we're going to be doing is what we're going to be doing. So today we're going to look at reducing C# debugging time with Ozcode Production Debugger. And we're going to deploy the production debugger with Pulumi. So the things we're going to take a look at, initially we're just going to do a quick introduction to production debugging as a whole. Then we're going to talk a little bit about infrastructure as code. And then we're going to go out and actually do things, and we're going to build a production environment with Ozcode and Pulumi. So let's go and do that. All right, so first a little bit of an introduction to Ozcode. So Ozcode started off building tools that are resident inside of Visual Studio that help you with your debugging process. So I have used them for a number of years. My largest use case is usually around debugging large collections. So Ozcode adds things like search and the ability to surface fields inside of the debugger much more easily, and to execute link statements and filter collections. But there's also a bunch of look-ahead debugging that will warn you ahead of time if you're going to hit an exception. And a really nice tool for exploring large, complicated mathematical equations inside of the debugger. So building on top of that technology, Ozcode has created a production debugger, which ties into your actual production system and lets you resolve problems much more quickly than you could with traditional application monitoring tools. So a little bit of background here on Ozcode. It was founded in 2014, and as I said, the initial product was a tie-in to Visual Studio, but that same technology is now being used inside of the production debugger, which is looking for general availability in just about 3 or 4 weeks' time here, so targeting March 20th. There's about 5,500 developers who are busy using Ozcode, and it's deployed in over 1,000 different enterprises. And you can see some of the big name customers down here at the bottom. So the production debugger, this meme is a popular one on the internet. I don't always test my code, but when I do it in production. But this is actually a fairly legitimate thing to do. So errors in production, although we try and avoid them, they do have a tendency to creep in. And there could be a number of reasons that bugs are making it into production, even though you have really high quality unit tests checking your code, maybe you have integration tests checking against databases and against third-party services. There's always these little gaps where things can sneak in. So it could be that a third-party service has all of a sudden started returning strange-looking data, or data in a different shape than you were expecting, or they're returning nulls when they promised they would never, ever return nulls. It could be something like users entering crazy data into your application. There is no better way to test your application for crazy input than to just hand it over to users and watch what they do. And even places where there has been a lot of testing and we think there's probably going to be very high quality code, we still see problems in production. So one of the things that I would call out is the Boeing Starliner, which is their latest entry into getting people into space. They had a test launch about a month ago now, and They had some problems during their launch, which resulted in the passenger pod not quite making it into the right orbit. So they had not one but two significant software bugs in that, and this is millions of dollars down the drain now because of this. So I can guarantee that they put a lot of effort into building and testing this code, and they still ran into problems in production. But don't abandon all hope. There's always ways around it. So one of the more popular approaches is to add a whole bunch of logging into your application. So I have worked on applications in the past where we gather maybe as much as 20 or 30 gigabytes of logs a day. We load them up and we parse them and we look for specific exceptions, but it is an overwhelming amount of data. And yet, even with those 20 gigabytes of logs, we would frequently run into production problems where we didn't have the right logging in place. So while we had a lot of logging, that one particular piece of code, which is throwing an exception, didn't quite have what we needed in it. So what we would end up doing is we would try and figure out kind of roughly where the problem was. We'd add a bunch of additional logging around that. We'd redeploy the application, and we'd hang around and wait for the exception to occur again. So sometimes the exceptions would be few and far between. We might not see another exception in that code path for a week, or it could be something that was happening very frequently. But once we had figured out what it was through the additional logging, we would be able to reproduce that in our local environment, take a look at what's happening in the debugger locally, and then put out a fix. And frequently we would add a unit test around that to make sure that it didn't happen again. We were very lucky in that we were running a microservice architecture, so deploying changes was pretty quick for us. We did a couple of deployments a day, typically. But if you're in an organization which isn't so rapidly moving, then this could take a long time to do. You could be doing cycles on this for weeks or even months. So what the production debugger does is it ties into your production environment. It doesn't add a whole lot of load to production environment. And what it does is it looks for exceptions to be thrown. So the first time an exception is thrown, you don't end up with really much more than you would get out of most other debugging tools. But what that does is it prompts the production debugger to instrument that code path. So instead of instrumenting the entire application, which could be time-consuming and heavyweight, we just instrument the code paths that we know are causing exceptions. So now the second time that that exception is hit, you'll be able to see full stack debugging information inside of the production debugger, and you should be able to track down the problem much more quickly. So still we would end up deploying a fix, but we would save out on that whole step of doing multiple deployments just to increase logging information. So that's kind of the idea behind the production debugger. And so we're going to revisit that a little bit later so we can see a live demo of it. But the other half of this webinar is to talk about infrastructure as code. So what's the idea behind infrastructure as code? Basically, we have come from a history where deploying applications into production is a little bit haphazard. So when I first started in this industry, deploying to production looked like building your application, getting a zip file, walking that over on a disk to the operations people along with a Word document, maybe 20 or 30 pages long, giving them instructions on how to set up a database, what configuration variables to set, those sorts of things. We would hand it over and we'd just walk away. And a week later, we get an email from the operations people saying, we've set up your environment. Invariably, the environment would be set up wrong in some way. Something would not be working. And that would be the fault of the fact that we had 20 pages of instructions to get it done. So it's very difficult for a human being to go through 20 pages of deployment instructions and A, not make a mistake when writing it, and B, not make a mistake when running it. So what we're looking to move to now as an industry is infrastructure as code, where we take our applications and we build our infrastructure programmatically. There's lots of different tools out there for doing that. What you're doing could be as simple as writing a PowerShell or a bash script to stand up server instances, or it could be something like Chef, Puppet, or Ansible. These were all very popular tools a couple of years ago, although I haven't heard quite as much from them in the last couple of years. But this generally provides a repeatable way of provisioning your environment. So if you need to provision a test environment, it's not a problem. If you need to provision or re-provision a production environment for disaster recovery, it's very easy to do. And it speeds up your process too. So you can run these things programmatically, and that's a lot faster than running it as a human. So the places that we see improvements that people are really interested in is that this reduces the cost of deploying environments. You don't make as many errors. You don't have to stand up extra hardware. It's quicker to re-provision or resize hardware. It is much quicker to do this because we have these scripts in place. We can just process them and run them very quickly. And this also reduces the risk. So one of the risks that people are very aware of is that there could be something that attacks your environment, you lose some portion of your environment to disaster or malware or hackers or something like that does damage to your environment, or even you discover a bug in your software that's an exploit that people could find and use against you. So if your deployments take a long time to do, if you're only doing one deployment a month or one deployment a year, then it's a big deal to spin up the resources to fix that in any sort of a timely way. If you're constantly deploying and you have infrastructure as code in place, then this really speeds up your process unless you reduce risk. So it narrows that window of where problems could occur and not be easily addressed. So all of the major cloud vendors have their own systems in place that allow you to build infrastructure as code. So the Google Cloud has Cloud Deployment Manager. On AWS, they have a tool called Cloud Formation Templates. And on Azure, they have a tool called ARM Templates. So each one of these is a slightly different language that you would use to build up your deployments. But in the end, it's all pretty much the same sort of thing, that you write a big long text file that describes your environment. You hand it over to whichever cloud it is, and they will deploy and provision resources for you, usually fairly rapidly. And all of these systems have a way of solving dependencies. So if you have a web server that depends on a database server being there, these will deploy the database server before they deploy the web server. So these are fantastic tools. They work very well. And almost all the resources in all of these clouds participate within those templates. So you can set up most anything just by using these templates, and you don't have to worry about using the command line or going into the graphical user interface to add individual resources. We're actually going to see one place today maybe where there is a little bit of a gap. The problem with these templates is that they're all written in different languages. So they are all a little bit different from one another. So if you have gone and learned ARM templates, there's very little of that code which can be carried over to CloudFormation templates. One of the solutions to this is provided by these other tools that provide a layer on top of the other templating technologies and allow you to write a single language for deployment across multiple clouds. Now, it could be that you don't have resources that need to be deployed to multiple clouds, but you do have some products within your organization that are deployed to different places. Having a single language makes it a little bit easier on developers, and something like Terraform supports, I don't know, maybe a dozen or 24 different clouds out there. So they'll support everything from the top 3 cloud providers, so your AWS, your GCP, and your Azure, right down to 12th tier cloud providers that nobody uses, like IBM's cloud. So Terraform has been around for a number of years, and it's written by HashiCorp, who you might remember also created such tools as Vagrant. One of the new entrants in this space is Pulumi, which we're going to take a look at today. So they have been around for perhaps 18 months now, and have a slightly different approach to the templating of environments. All the other templating languages that we've seen so far are written usually in something like XML or YAML or JSON, but they are descriptive languages that you just write down what it is you want the environment to look like. Pulumi takes a different approach in that they use existing programming languages. So you can build your stack using something like JavaScript or Python or .NET. And it means that instead of writing in just a declarative fashion, you can actually write code into your templates. And this unlocks a lot of really interesting things. So something like Terraform has a real hard time dealing with creating a bunch of objects that are all very similar. And that's the sort of thing that you might do inside of a loop. So a declarative language has a lot of trouble expressing a complex programming object like a loop. There are ways of doing it in Terraform, but they're pretty weird and contrived. For something like Pulumi, writing a loop in Python is trivial. So we're able to build up environments that are a little bit more complicated, a little bit more adaptable than you would get from something like Terraform. It also means that if you need to do external calls within your templating language, you could. So if you wanted to make a call to a web service and use it to generate a password, or make a call to a web service and have it figure out pricing models, and then dynamically make decisions based off of those pricing models, you could do that with Pulumi. So an interesting application might be to have a monitor running on your application to see how busy it is. And then you could just continuously run your Pulumi template and it would call out to the monitor, see how busy the application is, and make decisions on scaling it up or down based off of the results of that. Pulumi allows you to build up all sorts of different resources, so serverless, containers, Kubernetes, all your standard infrastructure stuff inside of the major cloud providers. At the moment, there's support for the 3 largest providers, so AWS, Azure, and GCP. All right, so that is almost the end of our slides, and we're just about to get into actual code. What are we going to build today? So we are going to build up an application on top of Azure. We're going to build a website. We're going to put a SQL Server database behind it. And we're going to add the Ozcode Debugger into that environment. So that is pretty much what we're going to build today. And we're going to build all of this in a .NET language in Pulumi. So we're going to use C# because it's probably the most approachable language. So let me jump out of these slides here and over to this environment here. So this is Visual Studio Code. What I've done here is I have set up the bare bones Pulumi environment. And I have done this. Let me just get out of this slide deck here. So I have done this by just calling the Pulumi command line. So the Pulumi command line is a tool that is installed locally on your workstation, and then you can also run it within your build pipeline. And installing it on your workstation is as simple as running a single line of code, which downloads the package in PowerShell and applies it to your workstation. Once you have it downloaded, you can run Pulumi new and then give it a name, and it will ask you a series of questions. And the result of that is basically this directory here, which contains a couple of YAML files, but these are really lightweight YAML files. I know we talked about getting away from them, but they contain hardly anything. And the majority of the interesting stuff is going to be in this program.cs. So I'm running this inside of Visual Studio Code. The only real plugins that I have of any importance here is that I have the C# plugins here. So this will provide tab completion and that sort of stuff inside of here. So the first thing that we want to do is we want to stand up a resource group. So a resource group is kind of the bare bones container inside of Azure in which you put a bunch of resources. So it allows you to group resources together. And a resource could be a website, a database, a serverless environment. Anything basically you provision on Azure is known as a resource, and they can all be put inside of a resource group. This makes it much nicer to organize your environment. If you've got dozens of applications or thousands of applications inside of your Azure instance, having resource groups in place makes it a lot easier to find things within there and group them together. It also makes it a lot easier to delete things at the end. So we're going to build up our environment here, and then at the end, we're just going to issue a single command, and that's going to tear down the entire resource group, leaving nothing behind. So first thing I say is a resource group, and that very simply looks like this. So we're going to stand up a new resource group. We're going to call it Pulumi. And that is pretty much it. If we were to run this template now, it would go off to Azure and it would stand up just an empty resource group for us. But that's not particularly interesting. So what we're going to add on to that is a storage account. And this is going to be somewhere where we're going to store a couple of files. So we'll just type this one out so you can see how easy this is. So we're going to do a storage account, and we're going to do a new account. Yeah. I'm going to call that storage, and we're going to provide some arguments for it here. Account args. So you can see this is just standard C# code here. And hopefully if it's having a little bit of trouble figuring out names inside of Visual Studio Code, but that's fine. We'll just cruise on ahead here. So let's put in a name and a few other properties here. Just change this to the right capitalization. So we have put in this container here. So this is going to be where we put some files to use in our deployments. And we have referenced back to this resource group here, and we've taken the name from it. So we don't have to follow the same strings down. We can refer back to other parts inside of the application and use it to build up our templates. So this is going to stand up our storage account. And then on top of this, we're going to have an app service plan. So an app service plan you can think of as a web server. And on that web server, you can deploy multiple different web applications. We're just going to deploy one here. So we have given it, again, the resource group name here, which we've taken from above. We're going to make this a website and an app service. And then here, this is one of those places where you could dynamically pull stuff in. So we're going to set up the size of this. We're going to make this a B1 basic web instance. So there's a number of different tiers for web servers. I won't get too much into those at the moment. All right, so the next thing we're going to do is we need something to deploy to this web server. And that starts off by just putting a new container inside of our storage account. We could probably even move this line of code up here, try and have some locality within our application here. So this storage account container, it's going to be private. This is where we're going to put a zip file that gets deployed out to our web server. Now we come into one of the cooler parts of Pulumi here, is that we want to put something into that container as part of our template here, so as part of our building here. So typically in something like Terraform or ARM templates, you wouldn't have the ability to do this. So they split up the idea of building up infrastructure and deploying code into two separate things. So the projects where I build things with ARM templates, I'll typically have like an ARM template build and an application build, because they're two separate things. But here we're going to combine them into one. So we're going to create a new zip file inside of our storage container, and we're going to base it on what exists on disk. So I have a very small application here on disk that I am going to push up into a zip container. and deploy out to our web server. So I have a question here. Will there be example code for this presentation we can download? Yes, the example code is already up on my GitHub. I will put a link at the end of the presentation so that you can find it. Or you can just guess what my username is. It's stims on GitHub, and it's probably the two most recent repositories up there contain the Pulumi code and the web application code. All right, so this is going to zip our contents. It's going to push it up there. And we're going to continue along here, building up the rest of this template here. So our next step here is that we're going to build up a database. So we don't actually use a database in our application, but what's the fun of building up a template without having a database as part of it here? So we're going to start by setting up a configuration for the database. And this is a generic entity inside of Pulumi that you can assign different things to and get different stuff from. So this is going to call out to what is like transparently in Pulumi some variables. So I'm going to ask for what is this SQL admin username that has been assigned. If one of them isn't found, we're just going to default to Pulumi as our username. Next, we're going to require a secret. So the secrets you can set in Pulumi by just doing something like this on the command line here. So I would call Pulumi configuration set, then give it a secret, which is going to be called SQL password, and it is this bunch of gibberish here that is going to be set as that password. So this allows you to do some password management and secret storage inside of Pulumi. If you were running this on an Azure DevOps pipeline, you might want to retrieve this secret from a key vault or generate it randomly, hand it off to Pulumi, and put it inside of a key vault. Really, either way is just fine. Carrying on here, we're standing up this SQL server. We're just going to call it Pulumi server. We're going to put it inside of that resource group and assign it the username and password that we got just up here. And then we're going to choose what version it is. 12 seems like a fairly reasonable version of SQL Server to run. I'm not entirely sure what that maps to in SQL Server version numbers, but that's a fairly recent one. Once we have the database server up, we're going to create a database on that server. So at this point, Pulumi, because you have referenced the SQL Server here, it knows that there is a dependency between this being built and between the database being built. So it will not try and deploy this database until the database server is up and running. And then we're going to give it kind of a tier. So this is going to be an S0 or a standard 0 database, which provides, I'm not sure what it is, maybe 100 of the comical made-up units of performance. So now we're going to have a database built up here, and we can jump right into our app server. So this becomes one of the more complicated things inside of our Pulumi template. So it's going to look like this. We have named it Pulumi Web App. We've given it a resource group name here, which is taken all the way from up here. We're going to give it the app service plan ID, which came from somewhere back up here. And we're going to give it a couple of variables to set inside of its app settings. The first thing we set is website run from package. So this is a fairly new feature inside of app services. It lets you run your application from a zip file. So traditionally, you'd upload all of your files to app services and then have it run from there. By using this run from package, we can just point this at the blob that we had up here. So up here, we generated this code blob URL with a shared access signature. So this is like a secret URL that gives you access to the blob that we uploaded to our blob storage. We're also going to pass in this Ozcode agent token here. So I'll just take a moment and hop over, and we'll take a look at where I got that from. So when you sign into the Ozcode Production Debugger, and that's available just at app.ozcode.com, you're going to be presented with a screen like this. And on this screen, you can see that I have this outrageously long and complicated secret here that I just need to pass into my application. There's also a fabulous set of instructions here. So I can drill down here, choosing any environment that I want, and there are great instructions for how to set this up. So we can see here, this is how you would install it on an app service plan. We could go back and see how to install it on something like AWS. And of course, there's support for multiple different platforms here, so we can run this on Windows or Linux without any difficulty. So this is what it would look like deploying this inside of Docker. And finally, there's also the ability to run this on your own local machine. So this will run you through the instructions of doing that. So this actual web application that hosts a production debugger is provided by Ozcode for you. So you don't need to set this up. If you do happen to be running in an environment where you don't have any connectivity from your web server out into the larger world, or where there are security concerns about sending anything from your application, even if it's just debugging information up to a company outside of your own, then you can run Ozcode on your own server inside of your own environment. So you can run the entire thing inside of your own firewall. All right. Sign up for the webinar. It's too late. I'm already here. So I'm just going to steal this URL from here. I already have it pasted in over here inside of our application. So this is going to just inject an app setting inside of your app service plan. Finally, I'm going to set up a connection string here. So this connection string is built up off of all the information that we got off of the SQL server. So the SQL server name, the database name, the password, the username, all of this stuff just ends up being pasted into this string here, which is going to be added in as a variable called DB. The final thing that you have to do, and this is an optional step, but I really like to do it, is you can provide some outputs from your application. So when your template is run, you might want to see some of the things that it has set because they could be generated. So I'm going to return here two different things. So I'm going to return the site host name, which is going to be something that's generated up here. And I'm going to return the storage connection string. So I could return additional things here. So for instance, we could return this database connection string, or we could return anything else that came from this application. So if we wanted to add something new here, we could take something, just randomly pick something up here. This code blog URL we could grab, and we could return that. And that would just output from the build, and you just be able to see that kind of on the command line. So that's something you can do there. All right, so we have got this entire application built up here. Hopefully we haven't typoed anything, and we can go and try deploying it, see what happens here. So I have already deployed this. So there's probably not going to be many changes. I didn't want to have you sit through a whole database deployment. But the command that we would run here is Pulumi up. So what this is going to do is it's going to go and compile this hopefully correct code that we've been building up. It's going to then take a look at anything that happens to be deployed already, and it's going to diff it. So it's going to find anything that it needs to change to bring the environment that is on Azure in line with the environment that you have defined within this file. So this will just take a moment to do its build. Because it is running on .NET, it has to do the actual build process first. Pulumi has support for .NET Core versions 3 and up. So I have version 3.1 of .NET Core installed on here, I think. So right now it hasn't found any changes it needs to apply because we haven't updated anything. That's a little bit boring. Let's cancel that and make at least some sort of a change here. So let's add another variable here into our web application. and we'll just call that right there. And we'll just run that again in hopes that things get a little bit more interesting this time round. I'll take the opportunity while this is running to go to log into Azure, because I think I failed to do that. All right, so let me take a look at my resource groups here really quickly, and somewhere in here I have a Pulumi one. There we go. So this is the resource group that Pulumi has built. You can see all the various different items in here. Let's see if it's done. Yes, so it has noticed that there is a change to the Azure website. So it wants to know if we want to update this. Let's take a look at the details on this. So it looks like we get a nice little diff here that tells us that it's added another variable here. So yeah, let's go and deploy that change here. So Pulumi is now going to call out and it's going to go and build this environment. Or I suppose make the minor update inside of this environment. All right, so we will let that run in the background. And we'll just jump over and take a look at our website here and look at installing the production debugger into that. So this is one of the places where there's a slight gap in what is possible with Pulumi versus what is possible in the user interface here. So you cannot currently install site extensions using Pulumi. I think it's on their roadmap. You can do it using ARM templates directly. So it's just a little bit of a gap that currently exists in Pulumi that I'm sure will be closed shortly. But if we search in here for site extensions, it's not called site extensions, it's just called extensions. In here, I actually already have the Ozcode Production Debugger installed. If I didn't, it would just be a question of hitting add, searching through this list here. So I would just hit the production debugger, accept the license terms, and hit OK, and that would get that production debugger installed. So that production debugger is very generic here. It relies on that connection string that you provided to, or the key that you provided to know how to talk back to where it's supposed to. So let's take a look at this web app now. It looks like this deployment has completed here, and you can see in the output right here, it's produced what's the endpoint or what is the storage connection string. So if you're very quick, you can go and put a bunch of stuff into my storage account, but I'm going to delete it at the end of this presentation, so you're not going to get long to use it. So now we have this set up, we can go and take a look at the configuration. We should have 3 variables in there now. Yeah, there we go. So this is that other variable that we just added in here. And there we go. So that has been enough to set up the environment. We have the production debugger in place. We have the application in place. And one of our outputs here was the name of the website that we built. So let's go copy that, throw it in a new tab. We'll go visit this website. So this will take a second or two to start up because I'm cold starting the website. But the application that I have up there is a pretty generic web application here. So this is just like a file new project on an MVC project. I shouldn't say it's MVC anymore. This is just a .NET Core web application. And the only changes that I have made to it is that I have updated the index page to contain a few calls, so something for us to make a mistake on and for us to throw an error. So what I'm actually doing here is I'm going over the first 500 numbers, first 500 integers from 0 to 500, and I'm seeing which ones of those are prime. So I'm using a prime sieve to do that, and then I'm going to mark off which of those primes are Fibonacci primes and which ones are these mezzanine primes. sorry, question here. Does Pulumi guarantee an order of operations when creating deployment assets? So yes, it does. Pulumi is smart enough to look at your environment and figure out what dependencies there are. So if we go back to our template here, we take a look at something like this app service here. This app service has a couple of dependencies within it. So it references a resource group here. It references an app service plan here, and it's going to reference the SQL Server down here. So part of Pulumi's run is it's going to examine the network of resources that you want to create, and it's going to find dependencies within it. So this particular resource will be blocked on creation until the resource group is built, the app service plan is built, and the SQL Server is built. So if you were to think about this, it would basically just be a graph that it would need to solve, and it's just going to look for how to build this up. So it's going to start at the leaf nodes and kind of build those out and then move up the graph. And it will have support for checking for cycles within the graph, because of course, if there are cycles within the graph, you can't actually deploy it in a reasonable way. So if I was to have something that depended on something and that thing depended on the first thing, it would fail the deployment. All right, so here we go. Here's the first 500 numbers and which ones of them are prime, and some little check marks here about how prime they are, what sort of primes they are. So Fibonacci prime is a prime number that also happens to be a Fibonacci number. And mezzanine primes are primes which are of the form 2 to the n minus 1. So 3 is 1 because is 2 squared is 4, subtract 1, you end up with 3. So this is actually a very useful tool for finding very, very large prime numbers. So all the largest prime numbers that we know about are all of this sort of prime number. Unfortunately, there is a bug in this application. So I'm going to add a little thing here, and hopefully we will get an exception. All right. So we'll just go and run this exception through here, and I'm going to switch over to the environment which has the right key in it here. So you can see here that I've run into this a few times before, this exception here. So the Pulumi timeline here will show me when there are exceptions. So I have this zoomed all the way up to a month at the moment. And I'm going to drill into this exception here. Now, the first time that I came in here, because it wouldn't be instrumented yet, all I would get would be a stack trace, and that would be pretty boring. But if I drill in here, then I can take a look at what the actual code is. Because this exception has happened more than once, I'm able to actually see what the code looks like and where the problems are. So I'm able to go in and I can actually see the values within here, what these numbers are. So this allows me to get a much better feel for what the problems are, and I can go back and I can fix these problems right away. So I happen to see here that if a primes count is less than 30, we throw an exception. Well, that doesn't make any sense. Why would we just randomly throw an exception because the primes were less than 30? So it must be that somebody has written this. It doesn't have a strong grasp for prime number theory and expects there always to be more than 30. So there is a way of figuring out kind of some loose bounds on the number of prime numbers that you would expect to see, less than, say, 500. We're just going to remove this check altogether because those little bits of logic are kind of complicated, involve logarithms and so forth. Most of the approximations do, at least. So we're going to take that out of here. We're going to go and rebuild our application. So I have another terminal open here that allows me to just go and do a .NET publish here. This is going to rebuild my application. It's going to reproduce the DLL files for it and republish it. So that's done. And then I'm going to go back and just run my Pulumi up again here. So this is going to go recompile my template, and it's going to take a look at the zip file that would be created by the change in the program. and it's going to go and deploy those changes for me. So we'll go and push this up. This will just take a moment to run here. So it's noticed that there's going to be a couple of changes here. Basically, it's just going to update the zip file inside of the storage, and it's going to update the app service for me. So we'll go and just run that. And while that's running, I'll just take you through. I'm just going to add a new application in here. Test 5. And I'm going to update the key in production so we can see what this looks like first time we encounter an exception. So you can see this does a really nice job of giving you a progress report. So it went and replaced that zip and it updated the app itself. So if we come back over here, I am going to go in and edit this token to be the new one and hit OK on that. Save these settings. And then I'm going to go and restart. I have unsaved changes. It's still waiting for it to save. There we go. Save completed. I'm just going to go and restart this application so it has an idea that there has been a change to it and it needs to send the instrumentation to a different production debugger endpoint. All right, so that has restarted, and we'll just go back to the site and make sure that it still works without that secret key in there. So this load may just take a moment. It's busy unzipping that directory and then starting the application up. So this is just a one-time hit the first time you deploy. If you are concerned about the time it takes to do this stuff, then the downtime for rebuilding, you can make use of a technology called deployment slots. So you can deploy not directly to your application, you deploy to a slot, which is off to the side. Then you can warm up that slot. And once it's warm, you can just switch the slots and it will redirect traffic to the right endpoint. All right, so this is still restarting behind the scenes. So we sometimes see these errors here just during a restart. We'll give it another couple of seconds here to load. All right, just have to leave that alone for a second here. But we'll drop over here. So this is kind of what the production debugger looks like. There are a lot of changes coming in the next month. Every time I say, hey, Omar, it would be really cool if the production debugger did X, Y, Z, he says, oh, we already have that. We just haven't deployed it yet. So there's still about a month to go before this hits the mainstream. So it's going to be a lot of really good changes here. You're just getting a sneak peek of it right now. But along the top here, we have the ability to filter down various different timelines. So some common numbers here, and then a custom timeline here. You can add additional users to your application here. So if you have an entire team that's looking at production problems, you can add additional people in here. Once this is up, we'll be able to see what an error looks like. Oh, it's still taking its sweet time to start up. Oh, Azure, you are embarrassing me with your slowness today. So I guess while we're waiting for that to go, if there are any other questions that people have, I can answer those. Everybody seems to be pleased. All right, well, we'll just give that a minute to load, I guess, in the background here. So I have a question here. Is it just exceptions that you can monitor in this manner? Yes. So the thing that triggers the production debugger to add instrumentation is throwing an exception. So anytime you have an exception actually percolate back up to the point where it returns a 500, it will be caught. And I think also if you log anything to the exception stream inside of .NET Core, it gets picked up. Is that right, Omar? I think we talked briefly about that, but I didn't get the full set of details.
Absolutely. So both logger.error, logger.fatal will be caught and shown in the production debugger. And it's important to note that version 1 of production debugger only helps you if the exception, the error or the bug actually manifested as an exception. But the version 2 of production debugger, which is coming later this year, also introduces the notion of non-breaking breakpoints. So that will essentially allow you to put a non-breaking breakpoint wherever in your you want in your code base, essentially mimicking the experience of debugging in Visual Studio, only you wouldn't actually break production every time a breakpoint hit. And that will essentially allow you to debug collaboratively with the rest of your team bugs and errors that didn't necessarily manifest as an exception.
Excellent. That sounds fantastic. I think that could be a very useful tool for a lot of people, having the ability to do that. All right, let's give this thing one more chance before we give up on it. No, it's still unavailable. All right. Well, unfortunately, it doesn't look like we're going to be able to show kind of what this would look like without anything, without the initial errors in it. But it basically just looks like a stack trace that you would get anywhere else. And then the next time through, you get the cool debugging experience that allows you to drill in and take a look at local variables and what properties they have. So a couple of good questions there. These are probably better for Omar to answer. I don't know what you're looking like for overhead on the debugger. I imagine it's fairly low because instrumentation is not applied everywhere.
Yes, so I can answer that. The Ozcode Production Debugger has a very, very negligible performance impact. It is by design less than 3%. We've sort of built the entire production debugger with performance as a feature in mind, in the sense that, as Simon mentioned, when an exception hits, we turn on this lightweight instrumentation, and it works similar in a way to an instrumenting profiler that you might use to catch performance issues, in that it's sampling. We can turn that instrumentation on and off dynamically, and in that way we're sort of self-throttling. We're employing a self-throttling algorithm to make sure the performance impact is always kept to less than 3% on the CPU. There was another question from the audience from Michael Demler, and this works with release builds and requires debug builds. That's an excellent question. One of the biggest problems with working with dump files, essentially, is that when usually the dump file is taken from a system in production code runs as release, which means that whatever local variables might be there, if you could only get a look at them, you might be able to crack the crash or the error that happened. But unfortunately, you'll usually just get the message that says the local variables have been optimized away because it's a release build, and things just happen to work that way. With the Ozcode Production Debugger, that will not happen. The lightweight code instrumentation will show you through the localhost window and the annotations on top of your code every single variable that could be useful on the code through the exception. And again, another very important difference here is that it will not only show you the moment in time where the exception or the crash actually occurred, but every line of code that led up to that exception. So giving you essentially a time travel debugging experience. All right.
So maybe a couple more questions there. How does Ozcode Production Debugging compare to the snapshot debugging features of Application Insights?
That's another great question. So there are several important differences. The first most important difference is that Ozcode Production Debugger as I just mentioned, gives you time travel to the exception. So as Simon showed earlier, you'll be able to see line by line every single thing that happened with the regular annotations that you might be familiar with from the Ozcode Visual Studio extension. So every expression that is true will be painted in green. Every expression that is false will be painted in red. You'll get these annotations that show you every single method that return value across every line of code. So essentially, the production debugger is trying to solve the problem of trying to reproduce bugs. You'll get the same level and depth of information as if you had reproduced the same issue on your personal laptop, hit a breakpoint in Visual Studio, and are now just stepping line by line through that. So again, comparing to Snapshot Debugger in Application Insights, it's again that moment in time of the crash, which is oftentimes just getting too little information too late. By the time the crash happened, you don't have the full context of understanding what were the events that led up to the crash. Whereas in Ozcode, you get the full story, the full timeline. Another big important difference is in terms of compliance and just the regulatory constraints around working with DOM files. When we're talking about production debugging, we're talking about DOM files, and by their very definition, a DOM file is a copy of the entire program memory at a given point in time, and that DOM file might contain, things like credit card numbers, social security numbers, phone numbers, etc., etc. So with the Ozcode solution, we never let a developer actually download a DOM file onto their personal machine. We only show you, what you should see. We control everything you see through the web-based debugging experience, and that means that we can employ redaction of personally identifiable information. And there will be a different webinar just to delve into all of those features, but in essence, they allow you to have good, valuable production debugging without sacrificing, compliance to the very, very stringent regulatory constraints around redaction of and keeping personally identifiable information safe and secure.
Great. Can Pulumi be used in sort of multi-stage Azure build pipeline? Absolutely, that's not a problem at all. All you need to do to have it work is install the site extension, which can be done either through an ARM template or manually as we did today. And you just need to have that variable as well. So running the app setting variable, so running in a build pipeline is just fine. All right, I don't know that we have anything else. Will the production debugger allow us to capture telemetry and reply locally? I'm not sure that I understand that question. Is a question whether we can run this on outside of Azure, like on a local instance? Well, I'll let Andre figure that out. And then, did you want to answer that question about the trial version, Omar?
Yes, absolutely. So the production debugger is free to try. There's a limitation on how many agents you can actually install, but there's no time limit. So you can just go in and try it out for yourself without paying anything, without putting in a credit card. Just go ahead and try it.
All right, great. And we're still targeting general availability in about a month's time. So that's going to be very exciting. And I'm sure there will be significant noise around that when it does go live. Playing HM off. Oh, I see. So the question that you have, Andre, I suppose, is if you were to capture a trace within the production debugger, would you have the ability to pull that locally and then replay it in, say, Visual Studio so that you could add additional debugging information to it. I don't think so. Omar, correct me if I'm wrong, but I think that the idea here is that you would largely just step into the Production Debugger web application to see it. So the Production Debugger is not going to give you like an entire memory image, because of course there are those security concerns that you might have credit card numbers or SIM numbers or something within that dump. So the debugging is kind of limited to inside the web application, but that does give you access to all the locals, and it should give you enough historical information that you should be able to debug any problem that you encounter. So go live is scheduled for kind of end of March. I think I had it in my slides there somewhere. I think it was the 22nd. We're up here, the 20th. So everything's still on track for that, and we'll send out a bunch of information closer to the time. All right, so I think we are pretty much out of time here, so I will just wrap this up and say that if you have additional questions, you can reach Omar at his email address here, and then you can reach me. The most expedient way to reach me is to just tweet me at @stims, and I'd be happy to reply. Production debugger questions will get much